Today we're going to connect two disparate networking worlds together, a full-blown token ring network with a Windows 95 machine on it, and my Ethernet-based retro rack. Token ring was a network technology IBM came out with in the 1980s, and it took a totally different approach than Ethernet. We'll take a brief detour looking at an interesting Cisco 2525 router with a token ring interface, but then we'll get a token ring module installed in a Cisco 3745 router. We'll get both of those routers on the ring, in fact. And after a little bit of Cisco iOS configuration, we'll be able to successfully communicate between the two networks. Let's get into it. This is a Cisco 2525 router I just picked up. It's from the Cisco 2500 series. It has the very typical cracked, broken Cisco Systems badge on it. That's pretty common. They made, I don't know, maybe 8 to 10 variants of these things. And I have several. One of them is actually in the retro rack serving as my terminal server for a bunch of gear in there. But this one is a pretty interesting variant. Let me pull out another more mundane one to show you why. On the top, I've got this 2501, fully intact badge actually. That's pretty rare. But this isn't rare. This is a pretty common variant, I think. Common loop right here. On the back, it's got an AUI port, Ethernet. You can use that for Ethernet. A couple serial ports, fast serial links, and this is typically how they made a lot of them. They're kind of hard configured with the ports. It was sort of before they were getting into modularity. Now, let's look at the back of the other one. On the back of this one, we do have some hard-coded stuff, but we've also got these modular bays. I don't think I even realized they did modularity in the 2500 series, and this one's equipped with some interesting stuff. It's got an ISDN BRI module. I haven't done any ISDN stuff yet, but I am slowly collecting the gear, and this isn't even why I bought this, but that'll be interesting to play with. We'll pull this module out and see what's going on with that as we take a look around. But it's also got a token ring port, both the STP and UTP. This was a pretty typical connector, the D-sub 9-pin thing. Yeah. We're going to do some token ring stuff with this thing. What I think I want to do, dude, I'm so stupid. I wanted to do token ring to Ethernet bridging, but this one doesn't have any Ethernet ports. And token ring to ISDN seems a little too adventurous at the moment. Okay, we're going to pivot a little bit. We will play with this. We're going to get this into a ring as a node, power this up, see if it works. But I've also got this module, a token ring and fast Ethernet module, so surely that will get us further. I don't immediately recall what router this goes in. One second. It goes in this monster, a 3745. Okay, so we're going to pivot later in the video. First, let's boot this thing up, see if it's healthy. We'll get it on the ring as a node. Then we'll probably get this thing booted up with this inside, make sure that's good. And then we'll build a token ring network together with at least one computer and see if we can't get some bridging going on. I don't really know. Well, I'm a little less excited about this one, I'll admit, but let's have a look around and see what it's all about. It's got a pretty ugly handwritten IT asset tag on the front. Some slightly more interesting ones on the side. Looks like it was property of the state of West Virginia, the West Virginia Insurance Commission. All right. Ooh, another one here. Region 7, Office of Technology. It also has all of the rubber feet installed. So it was almost certainly sitting on a shelf and wasn't racked up in a server rack. This might be the coolest sticker of all. It's got a Fast Mac Plus Madge sticker. So IBM was the big proponent of token ring, the biggest producer. Madge was basically the only other name in town, essentially making token ring gear. So Cisco must have gone with them for this one. Interesting. Let's see what's going on with this ISDN module. I don't think I've ever seen one like this. Oh boy. There we go. Didn't want to come out. Ooh. It's kind of ugly. There you go. Some sort of Motorola chip. A Lucent chip. Oh, Cisco logo there. Cisco Systems logo screen printed on there. That's nice. And then we've got a copyright 1995. Wonder what the chances are. I'm going to have to factory reset this, and it's got its original West Virginia Insurance Commission config on it. We'll have a look, maybe if so. Got it plugged in, got the serial cable going to my main machine. Let's see if it lives. It does, and right away on the screen, we're getting serial output. System flashbank 0 That's not good. NVRAM invalid. Uh-oh. Can't say that this is good news. I don't think I've ever seen system flash initialized failed. It is asking us for configuration details though. What we're going to do is just get into a default config here and try to write it out. But that might not work. The NVRAM might be bad. We'll see what happens. NVRAM invalid, possibly due to write erase. Seems bad. It detects all the modules. Oh, and then it starts over again. Oh, that's good. This thing is slow. Yeah. It does not have a valid NVRAM to store its iOS on. I can't remember what I can do here. It will let me configure the interfaces though. So this thing's going to need a little surgery, I think. Oddly enough, because it is able to load this minimal iOS into memory, we might be able to configure it live and get it on a token ring network, but we'll put it aside for now. Based on my energy levels, we might revisit that. That's okay though. It wasn't going to help us do any bridging anyway. On to this monster. This one does work, or at least the last time I powered it on it works. I've never really done too much with it, but let's flip it around here. And with any luck, assuming I read the documentation correctly, this token ring fast Ethernet module is compatible. It fits at least. That doesn't always mean it's compatible. And this one is loud, unfortunately, so that'll be fun in here. Same story, got it plugged in, console to the computer. Let's boot this big dog up. Oh yeah. It doesn't help that the fans in there are clearly in need of some bearing grease. They're pretty crusty. I've found that the larger the Cisco router, the longer it takes to boot up. So I do see a green light on the card we just inserted. That's good news. I'll be back when it's up and hopefully it recognizes it. It's up. It's factory reset. I'll have to look into that. I am not seeing the token ring interface. These guys right here are built into the machine. It already had those in its controller board. PCI Dev IA128 and it failed. This is going great. This thing doesn't have anything in it. Okay, let me do some research. It was supposed to just work with any iOS version in this 3745. I mean, right there. This is the card. I have a Cisco 3745. It says all Cisco iOS software releases are supported. Huh. In another document about these cards, it says the minimum iOS software required. iOS is what's running on that thing, by the way. For the 3745 is 12.2.8T. The thing is running 12.2.8R T2. All right, well, as always, we're just going to update to a newer version of iOS. You've seen me do that a million times before. I'll be back in a little bit. Well, I've been making some progress on getting a new version of iOS on here, so I'm almost done. I'll bring you along for the last steps. So remember how this thing was showing me the default configuration option? That's what a factory reset router does, and usually when you write out that configuration, it doesn't come back. Mine kept coming back because I had previously set something called the configuration register on this thing to ignore its startup config. That's how you can recover from unknown passwords and things like that. So I got that sorted, put the config register back in the right value. Now it loads up from its internal flash storage. I can persist settings. I have configured this as 10.0.0.200. This is connected to my retro rack network. I've got a little TFTP server over there hosting a new iOS. So running into some issues though. Let's do some Cisco stuff. So I'm at the router here, and I'm going to copy from a TFTP server to the internal flash. And my TFTP server is 106. This is the new version of iOS, and we're going to put it on the flash. Goes out to the TFTP, and I'm out of space. I should have checked this before I got this far. So you can do a dir. I only have one source of storage in there right now, the internal flash storage, and I got about 10 megabytes left. I need about 20 megabytes. So one thing you can do is I could actually delete the iOS bin that it's running on right now, It's all loaded up in memory. And I could copy it here, and probably that would work. And if things went terribly wrong, you can recover from that. But just for fun, I'm going to try to put a compact flash card in here because I just noticed it has a slot on the back. So right here, it's got a compact flash slot for external storage. I found a 256 megabyte card. Pop that in there. I think I can do that live. Let's see if DIR detects it right away. It did detect it right away. It says device slot 0 available for use, external compact flash inserted. I have no idea if there's anything on there. Let's say DIR slot 0, I think. How do I do this? Invalid media or no media in slot. I think we can format it. 1 second. I reached out for a web browser and started Googling, but one thing I'm trying to teach myself is to force myself just to use the help menus. And sure enough, there's a format command. Just for fun. I'm trying to... helps me retain it, I think, better than just copying and pasting from some Cisco community forums. I'm going to format slot 0, confirm. I don't care what's on there, I think. So now I can do dir slot 0, and we've got plenty of space free. So we're going to copy from TFTP to slot 0 this time. That same file, it's going to reach out and copy 20 megabytes over fast Ethernet, so it's not too painful. A lot of the time on these older routers I mess around with, it's 10 megabits per second, and you forget how slow that is. Also, it's TFTP. Maybe that's a limiting factor. I'm not sure how fast this is actually going, to be honest. Uh-oh. I've never seen it put an O for one of its steps. It's probably fine. It says everything cool. Let's look in slot 0. There's my bin, and I think I can do... Well, let me back up. What I want to do is I'm going to inform the config to boot from this off of that card rather than the iOS version in its internal storage. And I think it's boot system slot 0. And then I think you give it this thing. Well, no. Okay, 1 second. System slot 0. Paste. Uh-oh. I'm not going to Google it. I'm not going to Google it. There's no boot command here. Conf T. Do we have a boot here? We do. Boot system slot 0. Following along so far? Okay, we're good. And so let's show our running config. And now you can see when this config is loaded, it's going to attempt to use this iOS bin, I believe. We're going to write that out. Doing some system administration. I think we can do a reload. This is going to restart the router. I think it will use that fresh config we just wrote down, and it should attempt to boot off that flash card, and I'll be back. This is talking about the bootstrap version. That's different, I think. Things are not going well. Oh man, check this out. Possible hardware fault. Yes, all right, it's getting interesting. Why would it be mad about that? See if I can glean anything from this. So it did try, oh my gosh. It's just reloading and taking my console control away. It did try to load the new version, 12.3. Maybe that's not what I want on here. Interesting. Fatal error, parity error on master read. Oh boy. Oh, it does not like it. Okay, this is a whole thing we're gonna have to deal with. I think I can issue a break. So I issued a break command in my terminal, and now I'm in ROMmon. I'm gonna tell it not to boot from that anymore. And I will have to Google this. I don't remember which config register to set. 1 second. Actually, before I do that, I'm gonna power it off, and I'm gonna pull this module. I bought this module on eBay a long time ago. I've never actually tested it. So it's possible that this thing has a hardware fault. Maybe that's why we couldn't see it in the other iOS. I didn't read anything about this needs to be in any particular slot. There's 4 expansion bays on this thing. So yeah, let's get this out of here for now. And don't worry, if this doesn't work, I've got more token ring stuff we can use instead of this thing. The second pivot, perhaps. Okay, I'm going to power this back on. I didn't make any configuration register changes. It should try to boot the same way it did where it was having that hardware fault. Let's see what happens. Let's see what we get. That would be sad if that module was messed up. That didn't happen with the old version of iOS though, so I don't know. We'll find out. This is about where it crashed before. Now it's fine. Let's. Okay, that's okay. Let's write out this configuration. It upgraded. It removed some configuration things I don't think it liked from the old version of iOS in my configuration file. And I am running the version I want to be running here. Yes. I actually don't know if this is like what it should be running, but we might have to play the whole try a million different versions of iOS song and dance to get this thing to work. I'm going to power it off and I'm going to put it in a different slot. Anyone that did this, you know, I think this thing's from the early 2000s. Back in the day, is this what it was like? All this trial and error? Or is this stuff just getting old? Also, I probably just don't really know what I'm doing. Okay, that's in there. Let's just see if it likes that slot. It's also possible it was having trouble coming up with that new version of iOS and the old config, and maybe it wasn't perhaps related to this at all, but let's find out. Will it crash? I'm gonna need more coffee. I think we're okay now. Oh, we're in. So I can't really explain what was going on with that hardware crash. 1 second here, I'll let this thing do its thing. But right here, we know we now have 3 fast Ethernet ports. We only had 2 before, and we have a token ring interface. So let's get in here and do show interface, I guess. That's one of the fast Ethernets. The other one that was built into the machine. Here's the one on the card we just inserted. And here's my token ring adapter. Okay. This thing is set up for what we need. Let's power it off and make a token ring network. Now we're going to build a token ring network with at least 1 computer on it. Token ring is a magnificent beast. I've done quite a few videos on it. I'll give you the basics. So Ethernet, that we're all used to, uses a shared transmission medium. It throws packets out into the ether, as it were. Back in the day, you had to deal with collisions and back off and everything. That problem's effectively been solved. IBM took a different route with token ring. The computers are in a logical ring on the network. Only one is allowed to transmit data at a time using something called a token. That's effectively the idea. They're quite different. It is a small miracle every time token ring works. So hopefully we see some miracles today. The very basics you need to get a token ring network going are something called a MAU. This is a media access unit. You can think of it like a hub. You cannot directly connect 2 machines with their token ring network interface cards. You need a MAU to form the ring. Don't know how to explain it any better than that. There were a bunch of different connector styles, but a lot of the time the MAU is going to be using these IBM Type 2, I think they were called, connectors. Big chunky connectors that get in there, and on the other end there's usually 2 options. You had STP, shielded twisted pair. They usually had this 9-pin connector on the other end, or UTP, unshielded twisted pair, like this with the RJ45 jack. I'm going to be using UTP cables today, so we've got the IBM connector on one end going into the MAU, and we'll use this connector here going into the machines and the router. And check these things out. These were just pulled out of service. Well, I don't know if they were being used, but they were physically ripped out of whatever wall they were in. A viewer named Ketu sent these to me, so a huge thanks to them. And it gives us a pretty good idea what I'm talking about. So in this big one, there are several wires, I think just 4, and they're going to be twisted like you would see in an Ethernet cable, but they're shielded, as you can see. There's all the shielding around them. This one over here isn't going to be shielded, sort of like Cat 5 or whatever. Yeah, one day we'll get some permanent token ring ports down here installed. Over here I've got my trusty Windows 95 token ring machine. It's got a token ring network interface card inside of it. And it also accepts STP or UTP. We'll be using UTP today. This was pretty typical to have both of them. Earlier cards are only going to have STP. I think that was the original standard, for lack of a better word, that IBM came out with and was shipping. For example, here's an older IBM MCA token ring card for like a IBM PS2 machine. And you can see on the end there it only has the STP, and it's got a little 16.4 sticker. Token ring networks of this era ran at 4 megabits or 16 megabits. I think the first computer to enter the ring establishes the ring speed, and I'm pretty sure that IBM is set to enter at 4, but we'll figure that out. Now the plan here is to leverage the fact that networks have layers. They use the OSI model. At the bottom, you've got the physical layer. You can think of that as the literal wires or optical media that's being used. Hi, Chloe. She's going to help me explain, maybe. Can you move for a little bit? Sorry. So you got the physical layer, and then above that, you've got the data link layer, also called layer 2. Above that, the network layer, layer 3, and so on up to the application layer. So an application actually leveraging the network you've built. And this layered architecture is useful. So Token Ring and Ethernet are at layer 2. And I'm going to set up a TCP/IP network. So every node in my ring and off to my retro rack, they're going to have IPs. And they aren't going to care what's going on underneath. So basically, I'm going to be able to, I think, I'm going to be able to route from the Token Ring network over to the retro rack. And this stuff up here is going to be none the wiser because of the layered architecture. The network layer does not care what's happening in layer 2 and 1. That's the beauty of a layered architecture. So Chloe and I are going to get this Windows 95 machine hooked up. We'll insert it into the MAU. We'll power it up. It'll be the only machine in the ring. And then we will insert the router into the ring, hopefully. I suspect there's going to be a fair amount of troubleshooting just to get that far. And then we'll figure out how to actually route between this network, which will be on its own subnet. The token ring will be, 192.168 something. And then I'll allow routing over into the retro rack, which is a 10.0.0.0 network. Right, Chloe? Let's do it. Windows 95 is booting up. And I haven't been doing this token ring stuff very long, maybe a year and a half. And I know exactly the sounds this thing should make if it gets in the ring. So this is passive, it's not powered, but there's physical relays inside. And as the computer, a node, tries to enter the ring, might be trying now with that little gap, should hear some clicks. You probably won't hear them with these fans. In fact, it might have already happened. I might have not have heard them while I was talking because I'm seeing the green light. Ooh. One click. Anyway, it's kind of funny. I cannot imagine a massive data center with like thousands of token ring nodes on it. All the clicking and clacking that would be happening as things come and go, or if you have a network disaster and they're all trying to enter the ring, it'd be wild. So down in there, that is the network interface card, the token ring card, and it's got a solid green light, which almost certainly means we entered the ring. And as I was yapping at you, I heard the correct clicks from the MAU I wanted, so that's good. And then over here, that token ring interface is assigned 192.168.9.4. So we'll just stick with this 192.168.9 network. I will get the router on as, I don't know, .5 or something. And then we'll try some pings back and forth if I get that far. And then eventually, I will set the router as this thing's gateway, which means when I try to ping out to the Ethernet world after we do a bunch of Cisco config, I should be able to talk to the retro rack from Token Ring over to Ethernet. That is the dream today, which also means I could transfer files to this thing from the rest of my network, which would be pretty cool over Token Ring, I think. And then I don't know if we can see, this computer does a lot of networking. I don't know if we can see the speed, or if that's even settable with this particular card. If I click advanced, it freezes the computer. Yeah, Windows 95 stuff. Oh, we're back. I think that's saying it's at 4 megabits. Pretty sure. Oh, there it is. Network data rate, 4 or 16. I've never done a 16 megabit per second. I also don't know what's going to happen on the MAU if I do this. But let's try while we just have one ring node. I think this is going to want to restart. Oh yeah, the good old days. Hopefully you could hear that click. That was the Windows 95 machine entering the ring at 16 megabits. I've never done that before. How exciting. Now we're going to get this thing ready to enter our token ring network. So again, we're using this UTP port. I don't know if I mentioned, you can only use one or the other. They provide both, but one at a time is how it works. So we'll power this up, get nice and loud in here. This is going to be in shutdown, so meaning this interface is off by default. Don't think it'll cause any problems at the ring. I don't even think it's going to try to talk to it. A nice thing is I see down in here, it's got a couple useful indicators, whether or not it's in ring, and then 16 megabit speed. So I imagine that's off for 4, on for 16, and then full duplex I'm not going to worry about that yet. So let's power this thing up. Do some more Cisco stuff, shall we? Router is up, and I believe we can configure the token ring interface just like we would an Ethernet interface. So token ring, let's see what my options are. I guess it's token ring 0, maybe 00. What? Scrolled up and saw it. So it's interface token ring 3/0. Okay. And we're going to put it on the .9 network. I think .5 is what I was going to do. That should be fine. And then we have some interesting, probably an interesting speed option in here, I would guess. Ring speed. So we've got ring speed 16. Let's bring it up. No shut. See if it tries to enter the ring. Initializing. I heard my click. It says it's in the ring. No way. No way. It can't be this easy. I'm going to write that before I forget. The in-ring and 16 megabit lights are on. Can we ping the Windows 95 machine? We can. All right, this is getting spicy. Let's try to ping the router from the Windows 95 machine, and then we will progress from there. Let's see if we've got communication both ways. We do. So what we're going to do is add the router as this thing's default gateway. I'm guessing another restart, but we'll see. Yep. So what that's going to do is whenever I try to reach a machine that is on a different network, so for example 10.0.0.1, which is the RetroRack network we're trying to get into, this Windows 95 machine is going to reach out to this guy and say, hey, do you know how to get there? And this one's on that network. We probably have to set up some routing rules in iOS, and then we're going to have to deal with the RetroRack so that we can... Anyway, we're going to do some routing. So back on the router, I'm going to do a show route, and we don't have anything. I think we need to turn on IP routing. Maybe in comp T, IP routing. Sure. Can we do a show route now? No. Show route. All right, well, let's set up a route. This machine's on two networks, the RetroRack network and the token ring network. We know we can ping out to the token ring guy. So just for good measure, we can ping the default gateway of the RetroRack. And of course, we can get there. So we need to teach this thing, when it's got incoming traffic from here, tell it, hey, yeah, go out here. Take a look over there. I'm not explaining this very well. I was looking at the wrong route command. I'm using IP. Show IP route. There they are. That's what I was expecting. So I think I might not need to make a static route. It might automatically forward stuff to here for me. I guess let's find out. That did not work. We're learning together. Learn's a strong word because I've done this like 5 times and I can never remember what to do. I figured it out. I was missing a one-liner on the RetroRack router to establish a route back into the token ring network. So this is my network. Not all of this stuff is necessarily on at any given time. This is the main router. I'll show you the console of this in a minute, but this is 10.0.0.1. Now, the network we just created together is over here. This is the 3745 roaring on the bench next to me. It is connected up through the main router over that red Ethernet cable I was showing you. It's got an IP address of 10.0.0.200. It's actually flowing through a switch, but it can talk to this main router and therefore the rest of this 10.0.0.0 network. Now the 3745, of course, is connected to this MAU that we just set up. It's got an IP address on that network, 192.168.95. And then this little guy right here is my Windows 95 machine, 192.168.94. What was happening is I was trying to ping all the way through this infrastructure. We'd get to the router, and it didn't know how to get back to this 192 network. So let me show you the console of this HQ router. Here it is. And if we do show IP route, we can see I have created a static route. It says, whenever you need to get to the token ring network, go through the router that's sitting on the bench over there. Now we're looking at the 3745 plugged into the MAU, the guy on the bench. Sorry, I'm trying to make this clear. I know it's probably hard to follow. So I can do show IP route here, and I didn't have to set up any static routes. This guy already knows how to talk to both networks, so I did no additional configuration here. And so here I am at the Windows 95 machine. I'm going to try to ping the RetroRack router, and we get replies. We have connected the two networks. I suppose just for good measure, we'll try to ping another random machine on that network. This is the TFTP server we were using earlier. And we get replies. Incredible. Probably goes without saying, but I can ping the other direction. So let's log back into the RetroRack router, and we'll try to ping that Windows 95 machine over there. And here we are. Bam. Two-way comms. I never thought it would be this easy, to be honest with you. But the layered OSI model strikes again. We have a full-blown, legitimate token ring network, and I can talk to an Ethernet network in the other room. Do we dare? Should we try to insert this thing into the ring? It's in that weird mode where it's loading up like a really minimal iOS. I don't actually even know if I can like fully configure the interfaces or anything, but let's try it out. I'm running out of places to plug this stuff in. Got it on this MAU port here. Console's on. It's booting up right now. It's up. Again, I'm not holding my breath. It's got a corrupt NVRAM, but the interface is token ring 0, so we should be able to get in here and configure interface token ring 0, and we can. So let's do IP add 192.168.9. Let's call it 6, and then we want to do ring speed 16. Every device on the ring has to be the same speed. Let's do a no shut. See what happens. Initializing. I heard the click. I heard the click. It's up. So now what we're going to do is ping the Windows 95 machine. It worked. Yes. Okay, that was kind of pointless, but you know, we had to see if this old dog still worked to a degree. Got 3 nodes in our ring now. You can see on the indicator in ring, and of course I was able to ping the Windows 95 machine. Yeah, it's beautiful. I would say that went pretty smooth. This was one of those projects I was kind of dreading because I guess I had an okay mental model of how it would go, but it just seemed too good to be true that you could I keep saying bridging. We routed between a token ring network and an Ethernet network today. Yeah, really happy with this. Obviously, I can't keep with this stuff all on the bench, so I want to start figuring out a way to get some of the token ring stuff over into the RetroRack, and I'll run some token ring lines here. It'll make it easier for me to experiment. I don't have to set up the MAU every time and all that. So yeah, I'll probably do a video, sort of an infrastructure video sometime this next few months. I think it's getting pretty dire down here, as you can see from all my cables. It's pretty bad. So yeah, I look forward to that. Also, more videos on the way. I know I've been slow this year. In fact, I got a sneak peek. I'm pretty far into a Java Station video, but I got blocked. I'm waiting for some parts on eBay. So that's coming in the future as well. I transitioned over to this project. I wanted to really get this working. I've been thinking about this for a long time. It's going to be really nice to have these networks fully connected. Like I was saying, I can transfer files and stuff. Of course, there's a million other ways to do that. But it just seems like fun to be able to have all my token ring stuff. I have several machines that are set up for token ring, and now they can be fully incorporated into the RetroRack whenever I want, once I make this permanent, I guess. Finally hit 70,000 subscribers. My goal last year was 75K. I bumped that down to 70K, and I just hit it. So for anyone that is subscribed, a huge thank you to you for making the channel as successful as it has been. It blows me away that anyone watches these videos. So I guess I'll say, if you haven't subscribed, please do. The next goal is 100,000. If I make enough videos, maybe we can do it this year. As always, thank you for watching. I hope you really enjoyed some token ring shenanigans. If you really want to support the channel, I'm on Patreon. I post behind the scenes type videos. I did a big Collab Retro State of the Union video. Thanks once again. I'll catch you in the next video.